just as a very quick introduction, excuse me, just as an introduction, Geo Informatics, our tagline is "You manufacture, we measure." As you know, most of you are manufacturing organizations. Some of you today are from automotive, some of you are from tool and die shops, some of you are from aerospace, some of you I see are from government and defense. End of the day, you are manufacturing something. It can be a automotive vehicle, it can be a aircraft part, it can be a tool and die. So most important thing is you guys are manufacturing something. So when you're manufacturing, you require to measure those parts. So our organization is measuring those parts. Geo Informatics is a pan-India organization. I am, of course, right now calling from my head office, which is Ghaziabad. Apart from Ghaziabad, we have offices in various cities in our country, mostly from Pune, Hyderabad, Chennai, Bangalore, Jamshedpur, and of course, Delhi is our we call it a registered office. Wherever there is an industry, we are generally present there. As I said in the beginning, people who do not know geoinformatics, the name Geo we have taken from geometry. Since we do a lot of work with geometry, hence we call ourselves as a people working with the IT and geometry together. So geoinformatics is a combination of geometry, which is our science, plus IT, because all hardware, software are high tech, and we are using that for measurement. So reverse engineering, inspection are some of our activities. I will be talking today about 45 minutes, and last 15 minutes we will keep it for Q&A session. So you guys can keep asking questions at the end of the webinar. We are now almost 25 years old, practically said 22 years old, and quite a lot in, known for automation and metrology in government defense and in private organization. We are, as I said, located in multiple cities. Just small introduction about me, my team. We are led by various team leads in our country and trying to do certain activities pan India. Just a couple of slides to just give you a feel. When I said that you manufacture, we measure, we mean it. Yes, we mean it. You pick up any part. For example, medical companies say are making syringes. The syringes which are in a medical domain. We are measuring those syringes. Organization like Hindustan Syringes is one of our customers.
Sir, just a little interruption. Your voice is breaking.
My voice is shaking.
Yes, sir, your voice is breaking. It's from attendees only. The question is from attendees only. They are saying your voice is breaking.
I know today we are talking about technology and other technology is giving problem. Just give us a second. Let me disable Wi-Fi. It's LAN only. How about now? Is it better?
Yeah. Yes, sir, it is very much clear now.
Okay, let us continue
Yes, sir.
before again we face the same problem. Okay, uh, we are seriously organization doing support in measurement, be it automotive, be it a medical, or be it any organization related with any physical part. So from a physical part to a CAD model to a drawing creation, to the final inspection we are able to do. Are we able to do all such kind of things without depending on any other partner? Answer, unfortunately, is no. Geo Informatics works with almost 20 foreign partners, well spread over Europe to USA, and we are very well known for their partnership exclusively, mostly exclusively in India, and trying to do certain activities. This slide just tells you who are our partners. Some of the names probably you are already aware because you are using their equipment. For example, Hexagon is sitting in India also. They are our partners, obviously their partners, as well as they are doing direct as well. But many organizations like Microview, like HiQA, like Inora, Third Dimension, Itata, Veriserve, LMI, these organizations are exclusively married to us, married to Geoinformatics or associated with Geoinformatics, and we are their partner for many years now. Always customers are important. You all are our customers, some of you are our customers. So in electronic manufacturing service, some mobile phones, electronics, we work with a large. Are you getting? Mhm. Give me a second. I think voice probably is breaking again. Give me a second. Just check if it is a little bit better now.
Yes, sir, it is better.
Okay. Um, I was talking about my customers. So electronics customer, FMCG, even we work with Hindustan Unilever, Procter and Gamble. You must be wondering what Hindustan Unilever or Procter and Gamble will be doing in metrology. For example, Hindustan Unilever do a lot of packaging for shampoo, bottles, and stuff like that. Geoinformatics measures those very special bottles with the help of our machines, which I'll be presenting today. In medical line, we work with many customers. Some of the names are known: Indo MIM, Baxter, Dr. Reddy Lab, a company which makes inhalers, etc., etc. Biocon, for example. Aerospace, we work with many companies as small as, I will say, the people who have just started as a startup in aerospace companies to as large as Tata Aerospace or Boeing in India or HAL as a government organization. Automotive is surely one of our biggest domain. We work with many government defense organizations also like HAL, BEL, some NTPC, BHL, etc. In education domain as well, we work with IITs. Most of the IITs, most of the large institutes are working with us. So this was little introduction about our company. I'll be surely trying to move fast to make sure we focus more on the technical part of our product line. And I'm sorry, I'm just checking once again and again. I hope voice is okay. Okay, I'm being told voice is okay now. Coming to now, first of our product, which we call as a optical CMM or a machine, which is a vision measurement machine, or some organization call them video measurement machine. Microview is one of our partner. We work them from last 18 years precisely, and we sell their machines in India for high precision measurement. If I try to show you very quickly, maybe I can show you a little bit later as well, videos. This is how the machines look like. The complete machines look like a manual machine as well as, if you see on the left side of my slide, the manual machine. On the middle, you will see fully automatic machines. So these are the machines coming from Microview, USA. Probably you will not see this video. No worries. I'll show the video separately. I was just showing you the product in a faster way. I'll be coming back into details with the applications. Once you do vision system on such kind of machine, which are the fixed machine, you are able to measure in a standard room. You are not going to measure these parts in a very large speed. If we have to measure the parts in a very large speed in the line, we have a system from another US company called Cognix and Keynes. These are the camera-based system companies, and we use their sensors, the cameras, and able to do measurement in the line itself. These are the vision sensors. Many vision sensors are used and in the whole country for various applications. Code readers for accessibility purpose, the QR codes are becoming very, very common. These are everywhere, and we are able to read these barcodes, connect with the measurement equipment, etc., etc. So as I said, Cognix is one of our partner. We are not a very camera selective company. We work with the mostly high-end cameras only. So Keynes and Cognix are our two partners. We work with them and we develop multiple applications, what you're seeing here on your screen. Do not worry, I'll be coming to the specific applications. When we talk about 2D, we are talking about cameras. Just now we finished that. How about 3D? 3D means X, Y, and Z, all the three measurements. In that case, we are talking about another company from Canada called LMI. LMI is a company very well known for such kind of equipment, which we call as a point sensor, line sensor, snapshot sensor, etc. Just imagine you want to measure in the line itself the thickness of a plate. Can we measure the thickness of the plate using only cameras? Answer is not so easy. But such sensors, which we call profile sensors, laser profile sensor, or laser profilometers, are able to measure such kind of thing very easily because these are 3D sensors. We have developed some products which is made in India, are the smart products which use sensors, cameras, technology like PLCs, and we are able to do automation directly. So these are the special purpose AOIs. AOI stand for automated optical inspection machine. With the help of that, we can do such kind of thing. For example, some cover of the remotes are getting inspected automatically. In one of the slide, you see some of the covers from the Coke bottle are getting inspected automatically. Small part, large part, plastic part, even the rubber parts are getting inspected automatically. So these all are automation product line from our company. This is how the machines look like. Total, these are the total, I will say SPMs, where you inside we use technology, outside you use as a black box. You have to just put your part and the part will be indicated by the machine. Sometimes conveyor is not the right tool. Sometimes we have to use a robo. Geo Informatics and UR, Universal Robo or COBO, we work together in our country and we do complete automation using UR robos for various applications. What you see in this slide or in this view is a robo is trying to pick up a particular part from a bin, trying to keep it on the conveyor, and there is a sensor and conveyor. And the sensor quickly checks whether the part is good or not good. Again, inline measurement. Okay, so far we were talking about inline measurement, offline measurement. How about the drawing? When you have a drawing for measurement, or when you have a CAD for measurement, you
Sir,
need
your
to do
voice is again breaking.
Is it better?
Yes, sir.
Okay. Um, Today I think we have to manage somehow. Seems to be some issue with the internet. Uh, High QA is a company from US, and we use their software for ballooning both 2D and 3D. You must be wondering what is 3D ballooning. This is basically the MBD, model-based definitions. In fact, today, slowly in aerospace, Empathy is coming very heavily, and we are able to do balloon both on 2D prints, which are PDF files, as well as on the 3D CAD model softwares. Auto ballooning is possible. Apart from auto ballooning, HiQA is a ocean. It's a kind of application. We are able to do complete SPC. We are able to do complete real-time analysis and reporting. We are able to do PPAP. We are able to do shop floor data collection. We are able to integrate many CMMs, VMMs, profile projectors, vernier calipers, integrated with the help of this software so that everything becomes traceable, everything becomes connected. This is how some of the slides showing you SPC, trend chart, data collection, ballooning, etc. Just a very quick overview I'm doing right now. Of course, I'll be showing you some examples as I said earlier. Scanners, I think voice is okay. Industrial scanners are very important product for today's time. There was days when only probing was there, be it a portable CMM or be it fixed CMM. But now both in fixed CMM as well as in portable CMM, we have scanners. So 3D scanners plays very important role in metrology. What 3D scanner look like? This is how a 3D scanner look like. This is one of the blue light scanner from our partner Hexagon. This scanner is made in Germany from an earlier company called Icon, which was taken over by Hexagon Manufacturing Intelligence. When you say scanner, it is like a paper scanner. You keep a part within a couple of minutes, depending on the size and the complexity of the part. This physical part is going to be captured as a point cloud with a scanning accuracy of 10 to 30 micron, depending again on the size. For as small size part of 1 millimeter to as big as whole aircraft, this is going to be computed as a point cloud. Later, that point cloud can be converted into a GSS step file or a parametric file, etc., etc. Another scanner from a company called Hexagon, the same Hexagon called laser scanner using laser. When we are talking about scanning a whole aircraft or whole ship, you cannot do with the help of a small field of view. You require a larger volume scanners. Laser scanner from laser using laser tracker can scan 15-meter parts for one position, 1 5. 15-meter part we can scan using one position. Still, there is a necessity of handheld scanner as well. Sometimes what happens, there is a challenge of putting a tripod, things there use handheld scanners. So in short, we use in short we use both blue light scanner, laser scanners, handheld scanners, etc. for our applications. Articulated arms are also very famous one, where you use for 2 meter, 2.5 meter, up to 4 meter, of course. You are able to measure the fixtures, etc., etc., using such kind of machines. Audible, I guess. Okay. So far, we were talking about portable metrology. Within portable metrology, there is another very important device which we call as a gap and flush equipment. Let me change quickly one of my Wi-Fi again. I hope my voice is back.
Yes, sir, it is clear now.
I hope it will remain clear for next 1 hour.
Not now. It is again breaking.
Okay, let us try. Am I audible?
Yes, sir.
Okay. You were talking about gap and flush. We were talking about gap and flush. This is equipment to specifically measure gap and flush on any of the parts. For example, in this picture, you are seeing one Bosch equipment where there are some knobs are there. This Bosch equipment is part of, let us say, some vehicle or some kind of machine. Here we are able my voice is not is audible. Mhm. Let's talk about the gear roll testing. Our organization also provides complete gear roll testers capable of measuring the gear profiles. We provide shop floor CMMs, etc., etc. When we say shop floor CMM, it simply means uh, this CMM does not require a standard room. Wherever the manufacturing is happening, we are able to measure there and there itself. Coming to the software, we work with Polyworks, we work VeriServe. This is a piece of software which is required for both portable as a fixed CMM. Sometimes customer do have a choice. So we are okay with both the software, VeriServe as well as Polyworks in our country for high precision measurement using portable as well as fixed CMM. One another machine which we call as a surface metrology is quite important. When we have to measure RA value or RZ value, uh, this is this is important to have such kind of machines because portable CMMs or fixed CMMs can give you flatness, give you circularity, coaxiality, but RA, RZ, SZ value, S10 value, R10 value, not that easily. This is how the machines look like. RT 50 from France, Ultimate France is a small portable machine. On the other hand, other machines are not portable, they are fixed machines. We also supply CMMs, conventional CMMs. And important to mention today also here is Geo Informatics also have started machine tool division. And under the machine tool division, if you are able to read, we are having now CNC machines, EDM machines, laser marking machines. We are also having a VTLs, vertical turning machines, horizontal turning machines, micro machining, cylindrical grinding, surface grinding, any manufacturing requirement, if any company do have, they need to invest into some machines, VMC's machine. Geoinformatics serves with Herco. Herco is a US and Taiwan-based brand. We sell their machines for as a VMC 5-axis, double column, and turn mill center as well, with the addition of Y-axis. In grinding, we do a lot of work with Palmari. It's a Taiwan-based company. They have both cylindrical as well as centerless grinder. And for surface grinder, we work with another company from Taiwan called Sunform. This was little introduction about the product line of our organization. To make it a little bit more interactive, let me show you some videos which I hope I can show in spite of not so good internet today. I just want to show you videos. Give me a second. One second. I just want to show you the right ones. Let me start with very quick one for the 3D scanning, just to make sure we all understand when we talk about scanning, what we do with the help of scanning. Now we'll be talking more on the application rather than this is how the scanner look like. For example, you see probably the part, you see the part, it's a sheet metal part, and you see the arm nearby. We have, with the help of this arm, we are able to scan sheet metal parts in a very faster way, and we are able to capture the scan data. And with the help of scan data, we are able to measure the complete sheet metal part compared to the CAD or compared to the drawing. On the other hand, when the parts are a little bit complex, for example, this is a cabin or cab frame we call, you need to compare with the help of, I will say, complete CAD model. We are able to do that. These are some of the real projects we have done together with our customers. On the other hand, I'm just showing you multiple projects just to give you a feeling. Such kind of projects are very well commonly done in our country, whether say bike scanning or whether say two-wheeler scanning. End of the day, part remains same. The scanner keep changing. Example here, we are talking about a blue light scanner, and these are the very difficult rubber parts. In a rubber part, scanning is done without contact, non-contact. You keep the parts on some table with a warpage, and you need to control the warpage, and you need to put some kind of frictioning. And end of the day, you will get such kind of scan data after scanning. And of course, you need to make a CAD out of it. This was a reverse engineering project where we converted scan data into CAD and able to give you the CAD model. So idea was on the physical part to the CAD model. And of course, you have to keep the physical part on a fixture, scan the data, then make a CAD model. If I now show you some more examples, not only a small part, even as big as a truck parts, we are able to capture very, very easily. You see some of the parts from the truck. For example, this is the whole door of a truck, LH and RH. We did the scanning for one of our customer in India, and dashboard or IP panel. You see the complete thing. And even you can see the total time taken for the scanning. It takes about half an hour to 1 hour, depending on the size of the part. So why I'm showing you all this example is just to give you a feeling, whether it's a truck part or a medical part or a bike part or a automotive plus rubber part, we are able to capture. All these are scan data what we have taken for various plastic parts. Here you can see the steering. By the way, what for this customer is asking for scan data? End of the day, scan data is used for only three purposes. One is reverse engineering, which we call converting the scan data into CAD model. Second is complete 3D inspection. And third one is the rapid prototyping. Of course, nothing is magic. Sometimes you do face problem. For example, in a bumper, you see there was warpage. And if there's a warpage or deformation, we need to somehow carefully scan from both the sides. So Geo Informatics, with the multiple projects in hand, learned sometime a very hard way how to handle the warpage. Warpage is surely a problematic thing when we talk about scanning on a larger part. I also want to show you one very, um, I will say, special slides. It's an old one, but I want to show you. Handheld scanners, do not worry about the brands right now. But this is what we are able to scan all styling studio cars as well as such kind of parts within our country, whether it's a very shiny part or whether it's a clay parts, so that we are able to generate 3D scan data, 3D CAD data. This was little introduction about, I will say, scanning activities. Let me now little bit jump to equipment which is not a scanner, but a fixed machine. Uh, Let me try to pull the video. You are able to see the video, and the voice is also coming, I guess, from the video.
Video is having your voice is not coming to the video.
Okay. Here you see the fixed machine. This is not a scanner now. This I'm talking about a machine which is video measurement machine. You keep this O-rings and machine will measure automatically by using shadowgraphy. Just to tell you about Microview as the organization, Microview US is a very famous for high precision vision measurement machine. I'll be to save the time, I'll be jump little bit going in between. It is from 1959. Microview machines are not only vision system, these are the hybrid machines. Machine come along with the touch probe as well as third sensor is called laser sensors. And just now, about a year back, we have also released another sensor called chromatic monochrome sensor for very high precision height measurement. These are the three sensor plus vision, which makes a machine from Microview very high end and unique, meant for multiple applications. Size of the part can be as small as couple of millimeters to as big as 2 meters. Organization like LG, they are using our machine for the flat panel measurement. Organization like Hindustan Syringes, I'm talking about the two opposite, using the same machine, same microview, but a different model for for measurement of the tip of the syringe in Faridabad. So there is so much variation in the part of the different parts. I'll be also sharing with you or showing you very quick one case study which we did for Bajaj and one of their customers in Aurangabad. Use the same microview machine and aim was to measure such kind of parts of the engine. O-rings, pistons, piston walls, shaft, spur gear, dog gears, and other, very, very precise parts. So you can see that there were six type of O-rings and each type were having 50 parts. And we were given very small period, 5 minutes to 15 minutes. We got it. And of course, we got five number of pistons. We took about 30 minutes to program and we took about 1 minute per part to auto run. We also got piston rings, shafts, gears, spur gear in particular, and dog gear. And of course, that was a forged part, fork, and another part called magneto. So in summary, 30 different type of parts were given to us from the engine and total we measured 500 plus parts. Most of the critical dimensions were measured using single machine only, but sometimes we have to use, for example, surface roughness for the roughness values because you cannot measure the surface roughness with the help of standard metrology machine like vision system. So this combination of camera plus probe, we were able to measure these 300 parts or 500 parts of 30 variants in a very short period. And eventually, this organization eventually went ahead with the machine as well. and proudly they're using this machine for last couple of years now. I will be switching to very now further on a portable CMM. Just give me a second. Before that, let me show you one which is very famous one, the gap and flush. Showing again a video. Remember the gap and flush is a portable machine only capable of measuring gap and flush. So let me try to quickly run this video as well. This is from a partner called Third Dimension from UK. Example, this guy came inside the vehicle and started measuring with the help of this small gun in his hand, and he's able to give us the values. Principle is very simple. Wherever there is a gap of flush, you drop a line, it's a laser line. A laser line will also get break in the gap, and camera, this equipment has a camera and a laser. Immediately the system will be able to capture the gap and flush. Flush means the height difference between two different planes in very high precision, as high as 100 micron, 0.1 mm. We have various heads depending on aerospace applications or automotive applications. This is a very shiny part. Most of the automotive vehicles are very shiny. A lot of chrome is being used. So there was a time when our own equipment, first generation, do had a problem of measuring shiny parts or chrome parts. But now fifth generation equipment, which we call GapGun Pro 2 from Third Dimension UK, is capable of measuring very shiny part as well, including glass parts. Being a handheld equipment, you can always upload the picture of the part under measurement so that operator, the guy sitting on the shop floor, he need not to be engineer. He just need a person he is a person who's just trained, and he will be able to measure the complete 300 plus points, both inside, interior, and exterior of the car in less than 1 hour. For the finished vehicle and for the BIW, we will hardly take about 20-25 minutes to measure complete outside exterior dimensions. Heavily used by OEMs in our country. These applications are now aerospace. In fact, HAL, NAL, and some organization involved with the government projects are also using this equipment for very fast gap and flush measurement. I just want to show you one more before I leave gap gun. I just want to show you one quick slide. Just to give you that. If you see here, the various applications. We are measuring the gap, we are measuring the radius, we are measuring the edge radius. You can see the shiny car, the gap and flush. Here we are trying to measure the radius of the rod because this equipment projects the laser on the circular part and immediately system calculates the radius. You see on the top radius and on the left side gap and flush. We are able to capture the edge. Any edges which is having a very small radius can be captured. Some burr can be calculated. Countersink for the aerospace application where a lot of riveting happens can be measured very accurately in an almost no time. Angle measurement, weld and seal measurement are some of the applications which are there in our gap and flush. A little bit old slide. We do not have any more four heads. Two heads are sufficient. One we call as a T15, meant for aerospace application, and one T60, which is basically meant for automotive applications. To save time, I am leaving this particular application and jumping into very another subject which we call inspection manager from high QA. I was talking to you in the beginning, balloon drawing, how to balloon a drawing and ensuring ballooning as well as other things happen more or less automatically. As I said in the beginning, high QA is from US and the product name is called inspection manager. What you see here, you see a drawing with the violet color numbers 1, 2, 3, 4. We call as a one-click ballooning. Once the ballooning is done, you get such numbers automatically against each and every dimensions. Plus, it also create a Excel check plan. All the readings are done OCR, optical character recognition, and comes into Excel automatically. And then we are able to tell which machine we have to use. Some some part will be using with the help of CMM, some part will be measuring with the help of VMM, some with the vernier. All that kind of thing can be can be defined. All of you are having either CMMs or VMMs, surely. Hexagon CMM or Zeiss CMM or any brand of CMM can be interfaced with such machines. Just trying to show you the final protocol. Final report is a report comes like this, which is a balloon drawing with Excel check plan and with complete SPC analysis, etc. Of course, you can do FAI, first article inspection. You can do PPAP for NPD departments. That's a totally different modules. We can do supplier management, etc., etc. Uh, since today is a general purpose webinar, we do a lot of product specific webinar also. When you have a general webinar, since a lot of products are there, I need to move fast. But anyone who's interested in seeing detailed product demonstration of any product, including high QA, you can just contact us at any point of time. Before I leave this of high QA, I just want to show you one inspection plan, which is from the real life. This was the drawing, and you see on the drawing the grid location, what was the value, the tolerance, and the measurement tool, which is not yet specified. This is the first level of FAI. Even the GD&T dimension like circularity or point position or R15 radius, all are captured automatically. I should not use 100% automatically. Sometimes you need to pick up these dimensions because OCR do fails on certain, uh, I will say, confused drawings where certain dimensions are crossing each other, etc. But again, a topic which we can discuss in a different webinar or maybe one-to-one someplace. Now, coming back to geoinformatics, because geoinformatics not only does only and only I will say product sales, we do a lot of services as well. So now I'm just going to focus for a couple of minutes. We still have, I think, 15 minutes, but I'll take another 10 minutes to talk more on services of geoinformatics. Just take example. Of course, you can see a certain thing which I'm going to show you in the shortest period. Let us say your requirement is once in a while and you do not want to buy a machine, or you want to buy a machine but maybe next year. In that case, Geoinformatics has a dedicated business unit which we call as a MNC, Measurement and Consulting Division. Under that, we are able to take up your project and do complete project at your site or at our site, depending on the project. Let me open a project in front of you, real project. We got a chance to scan certain bikes. This was a brand A. This bike was scanned at customer side because this was a little bit project which required confidentiality at that point of time, almost 10 years back. Now all these bikes are released in the market, or rather many years back it has been released. You see on the left side the scan data. When you do the scanning, you capture everything. But when you want to make a model, this depends on your need. This customer do not want to capture, they want to capture everything, but only want to do the model of a couple of selected features. And then there was a bike B, and again bike B was scanned and modeled. Bike C or brand C, scanned and modeled. Brand D. After that, what? Comparison between one brand versus second brand. For example, a user of the bike is feeling more comfortable in one bike. What are those features? Maybe it is the distance, or maybe the length between two LH and RH handles, the width of that, maybe the height, maybe the symmetry, etc., etc. All these parameters we calculate with the help of our machines. So geoinformatics, since we have all the machines available, be it scanner or a CMM or a VMM or gap and flush, we are able to pick up projects and we are able to complete the projects at various sites. At this point of time, when I'm talking, three projects are going on parallelly in various cities in our country. So we have multiple machines, not only one machine, uh, which we are which we are deploying for various activities. This was I was showing you for the quick comparison. I just want to show you, do not worry on this. My other slide is opening. If you see here now, this was a scan data, and that was a mod. This was a model, this was scan data. You see various type of parts, not only one part, just a normal fan. Like you must have seen in various TV ads nowadays, even the fans are totally being changed compared to conventional fans. So geoinformatics works with such large organization and does all such kind of activities. This is a bone plate from a medical company. This bone plate has various slots or holes at various angles. We are able to capture them very accurately. Just example, many parts, small size, large part, bike part, plastic part, we are able to make scan and CAD model. Just an example. Okay. Coming back to more or less last section, we call as a automation. Geoinformatics is not doing only conventional metrology. From last 6 or 7 years, we also started doing automation. Let us see one of the example of automation. Because I'm showing you just a normal video. Some videos are very confidential. This is not a confidential movie. This is from one of our partner. You see this is the part, camshaft rather, and you are measuring this camshaft in a very high speed. I shouldn't say very high speed and normal speed, of course. And you're scanning it and capturing the complete data. In this cross section, we are able to measure various positions without going into any other place. In the site itself, we are able to measure. On the other hand, if I show you very quick one, as I said in the beginning, geoinformatics builds such kind of machines from LMI using LMI sensors and cameras, depending on the application. If you see now this part, which is coming soon on your screen. Once, yeah. Just a second. I just want to go back a second. Yeah. Now you see, these are the parts which has a nozzle. That nozzle need to be inspected only, and that too we have to measure hundreds of parts in a shortest period. What we do, we design a conveyor. On the conveyor, we put these parts, and then we put sensors. We'll show you. Fail means red, and pass means, of course, green. The part stands for a couple of seconds. This is the black color sensor where you see this locator. This is a blue light single snapshot sensor, and immediately system will tell you green. And here you see the values. And the second part comes, stop for a second, red, bad part. This part will be going to different tray or different conveyor. Like this, automation happens. Okay. Since we are almost 3:54, I will like to stop at this point of time and ask for some questions if you have any. Twinkle, you can enable us if someone has sent today, someone has asking some questions, I can try to answer that.
Sure, sir. We have one question from Mr. Herschel. Meanwhile, we are just about to end the webinar. If you have any questions, please put it in chat box. We'll make sure to answer it all. We have one question from Mr. Herschel, sir. What is your solution for FMCG with heterogeneous mixture product for dimensional accuracy checking?
I just want to understand the question once again.
What
Yes. Can you repeat FMCG up to FMCG? I understood. What was the question?
his question is, what is your solution for FMCG with heterogeneous mixture product for dimensional accuracy checking?
Okay, got it. Very nice question. Heterogeneous dimension means some place tolerance is in micron and some place the tolerance is in sub millimeter. If I'm correct. So what happens? This is common with not only with FMCG, with every place. When your dimensions are mix of very accurate in microns to less accurate like zero point 0.1, zero point 0.2 millimeter, what we do in our company, we first calculate how many dimensions are. When we do ballooning of the drawing, we come to know from the tolerance chart, out of 100, 15 dimension require less than 10 micron. So we put against that 10 micron dimensions a machine called VMM. Then we see there is a dimension, maybe 20 dimension, which are just a linear dimension with a tolerance of zero point 0.1 millimeter. We put VC, 1 year caliper. So logic is very simple. If you have a part with a multiple dimensions, with the multiple tolerances, you need not to use single machine. You can use mix of various machines, or if your time permits, a high accuracy machine can always measure low tolerance object as well. So this is how anyone will do it. So answer to your question is beat FMCG. Like if I talk about particular FMCG, the bottles in fast moving consumer goods, most of the time I see packaging, very complicated bottles. Bottle neck is having thread. Such kind of thing we measure with the help of mostly with the scanner or with the help of VMM, vision measurement machine. These two are the right machines for both of them. Maybe I have answered this question.
Sure, sir. Next question is from Mr. Harish. The question is, can we extract isometric view post scanning?
Okay. Uh, I will differentiate here between scanning and modeling. As I said in the beginning, scanning job is to just capture physical object and make it 3D point cloud. After that, someone need to make CAD model from the point cloud to IGS or step file. When you have a IGS as step file, then of course we can create a 2D drawing, which is basically a 3D isometric view as well. So answer is step by step. Scanner itself will not do everything. Scanner will only capture physical object to the digital domain object. Then we do the CAD model. From there we extract all the views, including isometric.
Next question is from Harshal only. Post and data. How to extract the dimension of heterogeneous shape-like models?
Mm, just Twinkle, your voice is not coming to me. If you can come to this room itself, or maybe you just speak again. Just speak again.
So the question is how to extract the dimensions of heterogeneous shape-like models.
Heterogeneous models. I'm not very clear about this question. Maybe if I can take such number, I can try to answer that maybe one to one.
Sure, sir. I'll just mention that. The next question is, can uh, can we able to measure drill bits and end mill headers?
Okay. This is also very important questions. If I understood correctly, hand mills and drill bits or any cutting tools, can we measure it? Again, this is what the beauty of geoinformatics is. Geoinformatics do not believe measuring everything with the help of one machine only. So we work with the. I did not, of course, touch that. In that machine, we are able to measure all kind of cutting tools, including drill bits and end mills. But that machine is a special purpose machine only designed to measure and do the setting of drill bits or cutting tools before you start using it in the VMC machines. So answer is yes, and geoinformatics do provide such solutions.
The next question is from Harish sir only. Are you into virtual reality?
Well, we have started a department called Smart, as I was telling you, which is a more automation department. One of the word under Smart is, let me put the name Smart is, S stand for sensors, for measurement, A for automation, T for technologies, for future. One of the technologies for future is AI. Of course, AI is no more future now. AI is used in many applications today. So what I will say, not yet. We are not in a virtual reality. Maybe in metrology domain, virtual reality is not that much right now. Maybe, but in the future, who knows? We have this department who is working on such kind of future-oriented applications, including VR and AI.
Sure. The next question is how you will convert scan data into STL format.
Well, scan data is itself is a STL file. Maybe the question was how to convert STL file into step file. Maybe I can answer that both. That is not a problem. Once the scanning is done, we have to use software. Now, there are special purpose software like DesignX, which are very capable of converting STL into step file, or like in our company, we depend a lot on NX. So UGNX or Siemens NX software, we work to convert STL file into step file, but again, it is not a magic. It again goes very manual way. Model scanning may take half an hour, modeling may take 3 days. So modeling is a very time consuming and manual activity.
Okay. So the next question is how we can check dimension of bearing.
Bearing. Okay. Bearing is also a very special thing apart from bearing cage. Bearing has two parts. One is the bearing balls, and second is bearing cage. Bearing cage is simple ID, OD, and stuff like that. And the inside balls, of course, bearing cage also requires surface roughness, surface what we call surface finish. On the other hand, the bearing parts, the ball parts require very precise diameter, OD, ID, surface roughness, and stuff like that. So geoinformatics again have solution for this product as well, mostly vision system. And we also work with Taylor Hobson. our partner from a company called MTEX. Many of you know that, and we use their machine for checking bearing, balls as well as the cages.
The next question is from Mr. Prantham. How much
Hmm.
time it takes to measure drill bits and accuracy of the dimensions?
Okay, drill bits, or like when you want to do, let us say my VMC is ready and I want to put the drill bit there. So there is a machine I was talking to you from a organization called Saproni. It's a Italian company. It takes very less seconds, some seconds, to check the dimension of the drill bit, and we do something called setting as well. One is the inspection of the drill bit, second is to produce the parameters which we feed in the CNC machine along with this drill bit for the machining purpose. So it is all couple of seconds and minutes activities.
The next question we have is from Mr. Harish. Is there any instrument for measuring thickness of paint?
Okay. Uh, very important thing, because this is what is happening now. Paint also has a thickness. Geoinformatics so far is confined quite a lot towards dimensional aspect of metrology. When we say dimensional aspect of the metrology, means anything to do with dimensions. Paint thickness is of course a kind of dimension, but unfortunately we do not have that at this moment. I know, since we are in this domain for many years, so I know there is a technology available. I can name that, maybe I can name not now, but there is technology available which can measure the paint thickness as well.
We are done with the question answer, sir. We can wait for 2 minutes if there is any other question.
Yeah. Please feel free to ask any questions, because, or not only today, maybe you can send us a mail, you can visit us. As we said, we have many places. We're working with most of you one to one as well. You can send us emails, etc., etc. One point I would like to mention, uh, if time permits, our website is also designed in a way you will get a lot of information. I'm just opening that. I'm not sure whether you are able to see the website. You are able to see that. Anyone can log in into website gicpl.com. Just go to services. Here you are going to see our 3D inspection services, reverse engineering services, site inspection services, tool and mold design, 3D printing, consulting, calibration, staffing services, laser tracker services. Let us say someone was talking about, reverse engineering, how much time it takes. He should go there, just click here, and you will get some answers on this. Like a little bit about our company, what are the scanners available, how is the reverse engineering is done. For example, even we have shown a part how the step-by-step scanning happens, and we are answering this. We are showing some images. We have also mentioning, what is parametric modeling, non-parametric modeling. Once the model is done, how the 2D drawing is made, etc. etc. But this website is very, and I will use a word called knowledge oriented. So it is not just a sales or marketing kind of stuff. You can also use our website for any learning purpose.
So we
Now,
have
after
some more questions here.
go ahead, please.
From Mr. Tejpal, can we check all dimensions as per drawing of bearing race, not ball and cage, except surface roughness and etc.?
Okay, got it. Since I do not know much about the bearing details, so for this I need to surely, uh, I will say, consult one of our engineers. So, sir, I can reply you. not at this point of time because I know mostly bearing cage and bearing balls, but other things surely my team must be knowing it better than me. So this answer I want to do it in coming days along with my team.
Sure. The next question is from Mr. Ravi. In ballooning drawing software, how software take measurement instrument data?
Oh, very important. Very nice question. Software has no way to figure it out if I'm just opening that product called High QA. Software has no way to figure it out if my tolerance is 10 micron. I should use the Mitotoyo VMM or Zeiss VMM or Micro VMM. It has no way. What it knows is, I'm just Sangeet, ma'am, Twinkle, if time permits, can I show a video very quickly to answer this also?
Yes, sir.
Okay, coming. Okay, if you see here, just showing you the something which sir has asked. Yeah. Now, if you see, this is the drawing, and let us say this was the perpendicularity with the accuracy of 0.003, which is 3 micron, with a datum of A and B, with respect to A and B. Now, this highway can only write a balloon number against that. Which machine should I use it? This decision we have to take ourselves. But I can have a drop down option where all the drop down options of CMM, VMM, whatever assets I have in my company, where this will be shown in the software, and I need to just pick and drop, pick and select. Just pick and select it. It is this dimension is going to be measured by the operator. Let us say I use a vision system for that. Immediately it is going to put a V there, and it is going to then our engineer will know this is going to be used for VMM. So this is the way, sir, you will be assigning various equipment against various dimensions. Highway software can only and only give you option of selection, but option of selection by dropping all the options. You need to pick one of that. Yep.
We have next question from Mr. Harish here. Which is better instrument for measuring OOC, tracker, or scanning?
OCC.
OOC.
One second. Okay, I think OCC what he means is out of circularity. Yeah. Very important question. This one also. When we have to measure the circularity, everything will depend on two things. What is the size of my part and what is the tolerance? Let us say I have a refinery shell of 5 meter diameter with a tolerance of 0.5 millimeter. I will use equipment like laser tracker because the size is 5 meter. So I'll use a laser tracker for such kind of large part where accuracy required is very tight. On the other hand, if the part size is hardly I think the question was not only the tracker or scanning. Your tracker can scan as well. Always scanning accuracy is lesser than probing accuracy. So I will prefer, or we will prefer always CCR, the corner cube reflector. Some people call SMR for highest accuracy and scanner for the less accuracy. I'll give you the accuracy range also. We work with the Leica laser tracker 8960 model. The SMR accuracy will be 10 micron, but the scanning accuracy will be about 30 micron. So always use, if possible, the probing portion. And if your tolerance is not very tight, you have a 100 micron tolerance available, go with a very fast mode of scanner in the laser tracker. So I hope I have answered that question.
Last question I can see here is from Mr. Rahul. He is saying we are facing one problem that while we inspect the part on different locations in VMM bed, then we observe result variations.
Can you repeat once again the first sentence, first half of the sentence?
He
They have
want
a
to
VM.
say we are we are facing one problem that while we inspect the part on different locations in VMM bed, then we observe result variations.
Mhm. Okay, calibration seems to be this is a issue of calibration. So machine must be calibrated. When we say calibration, let us say the machine size is 220 by 220 by 160, then for the whole bed of the VMM, accuracy will remain same. If accuracy is coming different at different location, there is a challenge of calibration of the machine because we when we talk about microview machines can give you accuracy of 3.5 micron plus L by let us say 200, which means if the part size is 200 millimeter, I have accuracy of 2.5 plus 1 3.5 micron. So irrespective where you keep the part, machine will give you the same accuracy. So check with the if you have a microview machine, check with us what is happening with your machine. If you have another brand, you need to talk to their people. This doesn't happen what you explained.
I think these were the questions only. We are already delayed by a few minutes.
And apologies for this signal issue today. But I hope most of my talk or most of my words were uh, properly understandable. But again, this is not the first or last time we are doing such activities. You can always contact us, you can always write us. We believe this method of online presentations does not take too much time of us and yours, but at least within 1 hour we can share a lot with each other. So from my side, from Geo Informatics side, from our whole team side, we are thankful. You have given us your time and looking forward to work together, either by having services together or maybe by having some products together. Thank you so much to everyone there.
Thank you so much, sir. Thank you for your participation in the webinar. I sincerely hope that our knowledge and insight gained from the session empower you all. Wishing you all the best in your metrology endeavors. Thank you once again. Have a great day, everyone.